Welcome to a windy Blacksburg, Virginia. I should start saying that this is a recorded session, and I don't think we will run through the entire hour, so should have plenty of time towards the end, where you are welcome to participate in a Q&A session, sharing your questions or opinions. So my name is Benny Forsman. I'm the business development manager here at Inmotion US. It's a little background. I have been with Inmotion since 2001. It doesn't feel that long ago, but when you start counting the years, it's been a while. I was first with Inmotion over in Sweden and have then since 2005 been here in Virginia. So moving to the presentation, I wanted to start with a few disclaimers. The first one is that the beauty of being asked to do this presentation is that the selection of applications is purely my own. So what I'm including here is just a general overview of different applications that I have paid attention to over the years. Number two is that there's absolutely no ranking between different applications here, or for that matter, between applications that I have selected and other applications that were not included. Number three, I will, and perhaps this is unfortunately, not reveal any major secrets here. The information here is either shared directly from the OEM that have done them, or it is information that already has been shared publicly. And for the final bullet there, in case you wonder, there are applications here that include components from companies outside the Zappi group. So this is not intended as an exposition of our capabilities, but rather intended just to show how different OEM are addressing or maybe even embracing electrification. My first little example here, this is a US company, Skylift. They have developed a hybrid version of a Digger Derrick called the MD6000E. And this has been done with a system implementation from Craft Fluid. I thought it was a reasonable starting point. These guys were actually awarded the 2021 electric or hybrid application of the year by the Diesel Progress magazine. So it's kind of an interesting setup where they have still the diesel engine, but it's connected to a combined motor generator with a clutch in between. So the operating mode is normally that the clutch is open and the vehicle will run on battery power alone in an all-electric mode. But if you close the clutch, start up the engine, you can run it in a directly engine-powered mode and recharge the batteries while you're doing that. One of the aspects of this is it offers the full performance of the standard model, and the biggest sort of specialty of this machine is just the quietness of it, that they can operate without the noise of the engine running at full speed. So there's less disturbance in the neighborhoods where they are operating. They can operate earlier or later in the evenings. But there's also a fairly significant safety aspect of this, where the workers can easily talk to each other rather than using hand signals for communicating between each other. I think that's a not neat and somewhat unexpected type of electrified machine or vehicle, whatever we call it. I'll stay with the green color. This is another, I think, quite impressive smaller company, Mean Green Mowers. This company has been developing quite a range of all-electric commercial mowers. These are very professional, heavy-duty machines, and they can do up to 8 hours of runtime on a single charge. I think all of their machines have individual dual traction motors, and they also then have individual electric blade motors that control the blade speed. So in comparison to a conventional mower, it's still very quiet. This one is very fast. With the batteries placed really low in the chassis, it has a low center of gravity, so it gets very stable on sloping grounds. It has one interesting feature around the cutting quality, where they will show basically the relationship between your travel speed and the load on the cutting motors. So if you start driving too fast for the cutting quality, you get the signal that you are supposed to slow down. So this is, to me, kind of a Tesla of lawnmowers. And as a little side note, they will do very grin-inducing wheelies if you really go for it when you accelerate. Moving over to slightly larger machines, I thought I should mention the Digger 1370T project that has been called the Tygon. And here I'm a bit partial, because I have actually had the pleasure of driving this machine and experiencing what a fantastic job they have done on electrifying this machine. So the company are actually releasing 2 parallel versions of this machine. One conventional with conventional drivetrain, and then the T version here, which is a full series hybrid machine. We can look a little bit more at the design. And what this one offers with the electric machine, the electric machine here is a premium version over the standard one. It's said to have up to 30% additional peak power. It has 4 individual wheel motors for optimized traction, so you get really full traction control on each single wheel individually. And one interesting feature of that is that you can still steer this machine even if you only have two wheels on the ground, which can be of interest when you're plowing snow or in any other way, sort of using the front bucket hard. It offers the possibility to plug it in and operate directly from the electric grid when stationary at the work site. And in those cases, the engine is completely off and you operate in a silent mode on electric power. They also have a feature where the operator can run the backhoe completely by remote control outside the machine. So now he can be sort of close to the bucket, looking at exactly at how he's digging. One additional feature of the electrification, which I think we see on a lot of machines that are well done, is that you can use the electrification also for improved performance and precision on the hydraulic system. So I remember one presentation of this machine over at the last Bauma show, where the operator they had taken the bucket off and put the different little fixture on at the back of the crane, and we're using the crane to pick up a beer bottle, open the cap, serving a glass of beer to people watching. And then at the end, they were stapling the beer bottles on top of each other. We're coming up to a height of 5 beer bottles. So there's an extreme precision in the movement of the hydraulic system, which you can get with the speed control pump. This is a very new machine. Development has been going on for a few years, but I did notice that the official sales release is actually happening here during second quarter of this year. I received a slide here from the manufacturer, so this one might be of a bit of interest. It shows sort of the setup. There's actually 3 combined motor generators that are either powered by the diesel engine or disconnected and just run as hydraulic pump motors. And then you have the 4 individual traction motors that are each connected to a 2-speed gearbox. So this one is actually running on a 90-volt system with a 44 kilowatt hour battery. As mentioned, you have the off-board connection option, but there's also an on-board charger for overnight charging. And quite a few benefits over the conventional machine. And at least from my own perspective, even though I'm very inexperienced in operating a machine like this, you could instantly feel the ease of use of a machine like this, where how smooth and responsive it was to your operator input. So definitely a very interesting machine that it will be fun to see how it's performing in the market space. I really wish them all the best in.
Benny, Martin Vanrom here moderating the session. We have a question that is asked here from Rod that we maybe want to answer. And the question is, do you think electrification would be able to replace hydraulic pumps in most applications? We are starting to see in multiple applications, but it's still relatively small. So what do you think about that part?
Right. So this is I'll put it like this, saying that I have no crystal ball, and if you would ask my wife, she would tell you that I'm wrong more often than I'm right.
Okay.
But my input would still be that I think that that's relatively far away, because when you have multiple hydraulic functions on a machine, it's relatively cheap to add up all these hydraulic functions running from a single pump, but it becomes rather expensive to put electric motors and motor controllers for each single axis. That said, I don't think that there's a totally black and white answer here, because we certainly do see applications where this is happening, where OEMs are developing equipment where all of the functions are electric, where cylinders are replaced by electric actuators, and the rotary functions are replaced by motors. But at the same time, I would also say we have seen a couple of cases where OEM have started two parallel development paths, doing one machine that is, let's call it electrohydraulic, and the other one is fully electric. And if I try to think back, I think that all of those projects have ended up with the electrohydraulic machine being the one that has been going to the market. So it's probably a bit of a longer run to get to the taking hydraulics completely off.
Okay, so yeah. Good. Thanks for that answer. We'll let you continue there. There are more questions coming through the Q&A session, so we will take them as we go here.
That will be fine.
Yeah, perfect.
Since I said at the beginning, I had the luxury of being completely biased in selecting my examples for this presentation. This was a project that I feel a bit of personal pride, not because of being directly involved with it, but because I was actually the one who approved the engineering resources for the system software development at the time when we still knew that there was not really a commercial project behind it, but it was really such an interesting technology demonstrator. This is as old as around 2002, was an earlier version of the machine that you see in the picture. And it was kind of an interesting project because it almost ended up being electrified by accident. The starting idea around this machine was to test the development where you had a variable track. So you could make the machine wider if the terrain was allowing a wider machine. So then you had a larger load capacity. But you could also then pull the axles in and make it narrower if the terrain was more difficult. So then it was more maneuverable, but you could not load as much. And then that was sort of the starting point of the innovation. But then that led to electrification because it was just too difficult to figure out a good way to create conventional axles that could do this. So by then putting electric wheel drives, you could create this variable chassis design. And the experiences over time was then realizing that the electrification was probably more interesting than the variable track. So this then developed into the Elforest company. Today that is a system design company over in Sweden that do general electrification projects. And I should probably also clarify that one reason why I thought that this was such a neat project was that very early in my career, I was designing forestry trucks for a company Valmet over in Sweden. So I sort of had a personal interest in this space. But the value proposition is quite good, how to say. The reduced fuel consumption has been proven in various scientific tests around the moving a certain number of logs the same distance and the same terrain. Of course, you have the emissions reduction, the reduced noise, significantly less wear on brakes and transmissions. And you have this performance improvement and operability that comes from all the 6 wheels always being independently controlled. So one of my really noticeable takeaways of seeing this machine in operation is that normally in the forest where you see a forwarder travel through the forest, you almost instantly get these quite deep wheel tracks where the tires are scrubbing the topsoil off. But with this machine, where the wheels are independently, wheel speeds are independently controlled, and they are controlled also in relation to the steering angle, there is no scrubbing. So it was very obvious that there's virtually no impact on the ground as you were traveling with this machine. From a specification perspective, this one was using a small 60 kilowatt, I think it was a Deutz diesel, but it's a pure diesel electric setup. So the engine was running at constant speed, powering actually 2 generators to provide enough power within that 80 volt electric drive system. And then you had 6 individual 30 kilowatt AC induction wheel motors. Just to give a scale here, it's a 10-ton
machine
with a 14-ton load capacity.
We have Benny, we have a question here from Risco asking, the 80-volt system seems to be very low for a machine of this size. Why such a low voltage? And did this lead to any difficulties?
No, I think the power range was quite well chosen for the project, but I would think that if you would do this machine today, you would probably run it at higher voltage. But if you look at the year 2002, there was really not much high voltage, high power components available in the market, and the ones that were hideously expensive. So one sort of interesting piece here was that this was really built with off-the-shelf 80-volt forklift components. Nothing of the hardware was specifically developed for this machine. So the wheel motors were individual traction motors from a 5-ton counterbalance forklift, and the generators were actually forklift pump motors, so were converted to run as generators. So I would have to admit saying that one reason for the low voltage was just that was what was available off the shelf. But at the same time, I think it also proves a little bit that I have a theory that the world has been fooled by the tool industry, where we have been taught that, you know, if I go to buy a hand tool and I get a 24-volt tool, this is so much better than that 18-volt. So on. At the end of the day, that's not necessarily the case, because if the total power requirement allows you to stay within the lower voltage range, then you definitely have a much simpler system design. I listened to a presentation yesterday from one of the colleagues at Delta Q talking about the various voltage range and how this mid-range voltage, well, maybe starting already at 48 volt, going up to 120 or something, you get away from the entire personnel safety aspect of it, and the amount of safety precautions that you have to make in the machine is significantly reduced. So, and maybe I'll share one little tidbit. I know of another fairly large machine that runs a surprisingly low voltage. And talking to the owner of the company, I was asking a little bit about that specific voltage choice. And he said, well, but you know, on highway, the automotive companies and the bus and truck manufacturers, they can afford to train their entire service organization how to handle these high voltage systems. And we're such a small manufacturer that we can't really do that. So we have to expect that there will be a lot of people working on our machine without understanding what they do. And we're such a small company that we can't afford someone killing themselves by not knowing what they do. So from his perspective, that was really a firm limit that they couldn't go higher than where they were perfectly comfortable that no one would get harmed.
Okay.
But it's an interesting question. I did actually partly bring it in here just to show this aspect that you.
So maybe if you were to do it today, I should switch on my camera here as well. So if you were to do an application like this today, would you use the same voltage level?
I would think today you would probably run it at the 96, just because that's a fairly common sort of 2 times 48 lithium-ion battery packs. So I think that's becoming more common than 80. But I don't know that you would really benefit going to, say, a 650 volt, because how to say, each wheel motor is still not that big. And it would increase the overall system cost on the machine more than what I think that you gain from a performance perspective.
Okay. Good. Thank you.
I'll move area, and here I'm not able to specifically talk about the manufacturer, but more of the application. And again, a perfectly biased. It's a personal favorite of mine because I absolutely believe that electrification can make wood chippers so much better than what they are today. Today, what you see, you have on these larger kind of commercial grade chippers, you have an engine that spins a really large flywheel, and the flywheel is what provides the energy for the chipping. And what this means is that, first of all, you have to run the engine at full speed to keep the flywheel up at speed. And whenever you start overloading the machine and you drop engine speed, it's a very slow recovery. It takes only five seconds. I don't know. But when you stand there and you want to feed the chipper, it feels like an eternity until it has recovered and come up to speed again. And the other thing today is that there's typically no advanced control between the engine speed and the feeder. So the feeder will keep feeding pretty much until the engine stalls. I absolutely can see sort of the when you do these as a hybrid chipper, you put an electric motor between the engine and the flywheel, and the electric motor is also, in a sense, a flywheel with the large rotor. But now you have an active flywheel there that instantly recognizes the drop in speed and will apply torque whenever it's needed. So it becomes a whole lot less likely to bog down, and it also recovers significantly faster, because as soon as you release the feeder, the electric motor helps spinning the diesel up to its original target speed. And now you can also then start communicating between the motor controllers of the engine side and on the feeder side, doing sort of smart feeding. So this is really then allowing use of a smaller engine while still improving performance. And in some ways, the most obvious level where this is happening or should be happening is taking engine sizes down to the 24.9 horsepower level, where you can simplify the diesel and get away from the after treatment systems. So my quite in my cloudy crystal ball, but this is really an area where I think almost all machines will end up having some level of electrification within a not too distant future. And if you're not electrified, it will be sort of a low cost, low end machine for less serious use. It just sort of, this is really driven from that duty cycle with extremely high torque peaks, and then time in between where you have kind of no torque. So it's an absolute ideal application for electrification. I'll point to another one. This has not been a great commercial success, and I'll be honest to say I think that the system integrators were just creating a too expensive overall system, which I don't really think is needed. But I'll use it as an example, kind of a thought-provoking example, hopefully, of where you can so easily move away from the PTO-driven hydraulics and electrify a function of the truck. I think we have all been sitting at a traffic light behind a salt spreader truck that sprays our entire front end of the car with salt just because it keeps spinning at full speed, regardless of what the truck is doing. So by electrifying both the feeder from the bucket and the spinner at the back end of the machine here, they significantly reduce the waste of the salt mixture, which means that they can drive longer distances before having to go back and refill the bucket. And you also have an automated shake function, making sure that the spreader itself doesn't get stuck when something gets wedged in there. So a whole number of interesting benefits to the system, which from my perspective should be able to be done fairly easily. So this is about a 5 kilowatt system, can be either a 12 or a 24 volt system. And the last bullet, which I haven't seen, but I would absolutely think that makes all the sense in the world to also not just sort of have that part of shutting the spreading down when you're stopping, but you can have it completely controlled to the vehicle speed so that you spread the same amount of salt regardless of how fast you're driving the truck. We see a few of these electrified units, but I'm definitely hoping and expecting to see more of them. Now I'm changing gears a little bit. I'll just talk about two different type of applications that I expect significant breakthroughs in the coming, let's say, a 5-year time horizon, which is a relatively short time span in this world. Electric steer-by-wire for a lot of this type of off-highway machinery is something that I think we'll see a lot of replacing the hydraulic systems. There's a long list of benefits that you get with the electrification. Obviously, the typical hydraulic systems now driving the machine and moving the machine, you're typically not using the hydraulics at the same time. Normal hydraulics on most machines are primarily used when you're standing still. But when you have the hydraulic steering, now you still have to spin the hydraulic pump at all times, only to provide the flow for the steering. And the steering typically uses very little flow. So you're really circulating a lot of oil for no reason at all. And you're heating the oil and you're wasting the energy and you have the noise from running the pump, all of these things. The biggest issue has been that there are no electric cylinders that will really do what the hydraulic ones have been doing. This is something that I absolutely see changing. I see a lot of development in this space, and I think the machine manufacturers will quite soon have very attractive options to electrify the steering function. And one driver on this is also the automation, because we see the efforts of automating a lot of machinery. And if you try to make it autonomous, controlling the direction with the hydraulic steering is challenging. So what I think we see is that the growth of the autonomous functions is sort of what has been a key driver for getting these products ready for the market. But then I think that also the conventional machines that are driven by operators will benefit from this electric steer-by-wire transition. And I think we'll see, so this goes a little bit back to that question about electric or electrohydraulic. There's definitely not all machines where you are likely to see a complete move to a steer-by-wire solution. But I think especially on the heavy-duty on-highway segment, we'll see a lot of development going to electric drive of the power steering pumps, because obviously you need the most flow during parking maneuvers when you're really idling the vehicle. So the current belt-driven systems are sized for full flow even at engine idle, which means that during 98% of your time when you're actually driving the vehicle, you're pumping way too much oil. So this is also an area where I think we'll see a quick conversion over the coming 5 years or so. And then to end on a slightly lighter note, I had to put in two funnier examples of electrification. This is the Rise of the Resistance Star Wars theme ride, which is using now electric AGV vehicles for the people on the ride. Quite a fun application. And the last one, I'll see if I can get this one to run. I have to admit that I think this is the first thing that would kind of make me interested on going on a cruise, but we may have all different opinions on that. I think that was my last slide, and we have a little bit of time here for additional Q&As if you have more questions, Martin.
Yes, thank you, Benny, for a really good presentation. And we have more questions from the audience here. The Marco is asking, why is the I just need to launch Tigon. Why this Tigon need 3 PMAC generators, and is it not enough with 1 or 2? I think that was one of the first slides that you had.
Yeah.
Presentation.
Because the total power need requires that when running this 90-volt system.
Mm.
If you would have only a single generator there, then the current would be getting kind of unmanageable in terms of both controller size and wiring.
Mm.
So it was a very good question. That
maybe you want to flip back to that section in the presentation. We can have a look at that.
Let's see if I can.
There you have it, yes. That gives a good overview.
So yeah, and so basically it is to some degree driven from the fact that these 3 generators are then matching the four traction motors and the from a power need,
yeah,
you couldn't have done it with just a single 90-volt generator, because you would have been too current limited.
Okay. Another question here on the theme of customers who is typically coming and asking for these solutions, would you say? In what phase of their maturity are they, like, thinking, okay, we done the ICE for so many years, we tried a little bit of going battery electric, or have they worked with battery electric for a while and then come to you, Benny, and ask more questions? Or maybe it's a variety of
It's a variety, but I must say that we are definitely at the breakthrough point for something that I'm sometimes smiling. I go back and I look at my own internal presentations from 10, 15 years ago, and I've been thinking that there are all these segments where electrification is bound to happen. And it was really, I have always thought that it was just around the corner. And I've been wrong about that. And I think that there have been reasons for that, sort of with the financial downturn in the 2008, 2009. You had all the emissions regulations kicking in that consumed OEM R&D resources a lot and whatnot. But what I see today is that the market is accepting electrification and almost demanding electrification in a way that wasn't the case 15 years ago. 15 years ago, it was more kind of an OEM push. Here, now we have this electric machine. You should want it. And today, I find that the customers of the OEM are expecting what they perceive as modern technology. So I would say we see a lot of every day there are completely new applications that we have never. I have never even known that these kind of machines exist. And these companies have never looked at electrification in the past because it was typically not done. But now it's sort of really around how do we do this? We know we have to do it. We just need to figure out how.
Yeah. So it's now really starting to gain momentum. It's not only the vehicle industry, it's also in the CE market, construction equipment market, and all the other markets that are picking up on the electrification, which is
and even how to say, even small companies that maybe manufacture 50 machines per year or something like that are trying to figure out how to find the right level of electrification, doing something that meets the customer's needs, but isn't so expensive that it becomes unsellable.
Yeah. Good. Thank you, Benny. We don't have any further questions from the audience. Thank you very much for sharing your extensive knowledge in this area and the history of electrification. You've been around for a while, so you've seen most applications. So don't hesitate to contact Benny for further queries on interesting applications. So
my pleasure.
Thank you very much.
Right. Thanks a lot.
Thank you. Bye, everyone.